Okay, we were given this system and asked to solve it. Of course, we could brackets around it and reduce it. But what we want to really do is use the augmented matrix. We just don't include the x's or the y's. Put a dot there. And it's understood that this means 12x minus 4y for 16, 16x plus 5y equals 11. Now we can just operate on the numbers. Now what everybody did was they multiplied the first equation by 16, the second equation by negative 12, or maybe by negative 16 up here and plus 12 there. Either way, you get, if you use the equation, you get 192x on one of them and negative 192x on the other. You add them and the x's are eliminated. Okay, that's a perfectly balanced step. That's good, but we want to make sure we understand the use of the augmented matrices. So first thing I do is I do the prime factorizations, and I notice that you have a common multiple of 4. Okay. In other words, 12 is 2 times 2 times 3, 16 is 2 times 2 times 2 times 2. You have this common denominator of 4, and the least common multiple is 48. Now, how do you get the least common multiple? You just start with either of these numbers. Okay. If it's going to be a multiple of 12, you have to have 2, 2, and 3 in the prime factorization. Now, 16. Okay. 16 has some things in it that 12 doesn't. Now, 16 doesn't have the 3, but it does have 4 2's in the prime factorization. So you take these 2's here, and you got to throw them into the least common multiple. Okay. Now, these numbers include all 3 of these, and they include all 4 of these. That makes this the least common multiple. This number is contained in this number, 2 times 2 times 3. 16 is contained in this number because you got 2 times 2 times 2 times 2. If you take anything out of here, that's no longer so. So this is the least common multiple. Of course, you write that as 2 to the 4th times 3, but that's 48. Now, what do you have to multiply by 12 in order to get the least common multiple? Well, you have to multiply it by 2 times 2. Okay, right here's 12. 2 times 2 times 3. You multiply it by 2 times 2, which is 4. So multiply the first line by 4. What do you need in addition to 16 to get 48? Well, 48 is this. 16 has the 2's in it. You need to multiply it by 3. Okay, so multiply by negative 3 here. Now, that's what you do if you don't want to work with big numbers. It's okay to multiply this by negative 16 and this by 12, for example. You just get bigger numbers. There's an advantage to doing it this way, and it's worth thinking about. Okay, anyhow, we do it. 4 times equation 1 gives us 48, negative 16, and negative 64. Negative 3 times equation 2 or line 2 gives us negative 48, negative 15, and negative 33. Now, you write down line 1. You write down line 1 plus line 2. And we get 48, negative 16, negative 64, 0, negative 31, negative 31. Then what do we do? Well, the first goal is to get a 0 here. Then we're going to get a 1 here. Then we're going to try to get a 1 here. Zero here, and one here, and one here. We gotta do it in that order. So we got 48, negative 16, negative 64. That's equation one. I will note that I could have divided equation one by 16 and gotten smaller numbers here. And that would actually be a good thing to do, but I don't want to confuse the issue with an extra step that's really unnecessary, although it's convenient. So I'm not going to do that. But I'm going to then divide equation two by negative 31. Because why? That's going to be a one here. Okay, so I've got my zero, and I've got my one, and now I've got one. Well, this tells me that y equals one. And now what do? I add row one is 16 times row two. Well, 16 times one is 16. I add that to negative 16, I get zero. And 16 times one is 16. I add that to negative 64. I get negative 48. Now, there we have it. Now, again, I've got okay, I'm just going to write this again as row one and row two. You got enough room in your paper, it's not necessary to rewrite it. And it's not absolutely necessary in any case. But then we do row one divided by 48. Row two, we get 1, 0, negative 1. Now we can interpret this equation. First row is just 1x equals negative 1. Second row is 1y equals 1. And then we check. Got 12x minus 4y equals 16. X equals 1, negative 1, and y equals negative 1. Oh, something's wrong here. Doesn't check out. Gives me negative 16. So I must have done something wrong at some point. Okay, so I plug negative 1 in for x and 1 for y, I get negative 16, not 16. Took me a minute to figure out what I'd done. Well, after I wrote a negative on 16 here, I just wrote a negative on my 64. But multiplying 4 by 16 doesn't give me negative 64, it gives me 64. So now I have to correct some things. Process was correct, but I got careless and made a sign error here. Okay, 64 negative 33 is positive 31. And when I then divide row 2 by negative 31, I get a negative 1 over. Okay, so I've got a negative 1 here. And now when I add 16 times row 2 to row 1, I'm going to have 16 times -1, which is -16. 64 is positive. -16 and 64 gives me 48. So this is actually pretty easy to correct with just a little cross-outs. Okay, so now x should be +1 and y should be -1. Now, if I put in a +1 here and a -1 here, I don't have room to put the negative sign in, so. Okay, so I got 12 times 1 minus 4 times -1 equals 12 plus 4 equals 16. So by putting this in here and this, I agree with my original equation. And then my second equation is 16x plus 5y equals 11. If I plug in 1 and -1, I get 16 times 1 plus 5 times -1 equals 16 minus 5, which is 11. This checks, so now the solution completely checks. Fortunately, my error was on this term, which didn't really come into play until near the very end. So it was easy to make the correction. If I'd have made it on another term, I probably just had to go back and start over. And the last thing we want to cover here is how to multiply a row by a column. And ultimately then to multiply matrices. So there's another way of representing the system we just looked at. Okay, row times column. This is a row. And this is a column. Okay, so I've got a row, goes across, we got a column. Okay. Can you multiply the first number in the row by the first number in the column? Well, we don't worry about actually multiplying it, we'll just write it out. We'll write out first number in the row times the first number in the column is 5 times 2. Okay. Now, what do you get? And I'll do a plus here. What do you get when you do the second number in the row by the second number in the column? Just write it out. What times what? And then the third number times the third number. So you're matching these numbers up. You multiply these, you multiply these, and you multiply these. You just go down the row and you go down the column and get the numbers that have to multiply. Okay, we have a row and a column. Multiply the row by the column. We multiply the first number in the row by the first number in the column. Second number by the second number. Third number by the third number. Always a row, a number from the row times a number from the column. So the first number times the first number is 5 times 2. Second number times the second number. Well, people wrote this out, wrote it out carefully and correctly. It's 7 times 4. And then third number times the third number is 3 times 6. Now you can do the arithmetic. Well, we're not going to bother with the arithmetic as far as explaining it. So that's 10 plus 21 plus 18, which is 39 if I didn't make a mistake. Well, that was 7 times 4 is 28. I saw the 3 there. Okay, so it's not 39. Number 7 is probably 46. Okay, that's 46. So this row times this column equals 46. Give you another row and column. Now, all I want you to do is write this out. I know you can punch that into your calculator. You probably do a lot of it in your head. Let's take 8, 12, -3, 4. Multiply that by 5, -14, 2, 7. Again, just write it out like this. Don't bother doing the arithmetic because you can always do that easily. All right, now we want to write this out pretty carefully. You've got some negative signs in here, and that can cause confusion and error. So anyhow, we do the first number times the first number. That's 8 times 5. And then it's plus 12 times -14. Probably want to put that -14 in parentheses so you don't mistake it for subtraction. Okay, and then -3 times 2. Now I'm going to do plus -3 times 2. And then it's plus 4 times 7. And I don't really need parentheses there. But since I've been using them, I'm going to. Okay. Now, if you went ahead and did the arithmetic, that's 40 minus 168 minus 6 plus 28, 140, 180. I think 174. Everybody do the calculator get 174? No. Anyhow, I'll put a big question mark on that. And it isn't 174. As I started losing track of my signs, let's do it again. I got too tricky on it. This is -140, that's -146. So that's, I think, -106. Is that right? Good. Sometimes I get it right. Okay. Well, now let's look at another one. That be. Okay, now before I do this, let's reiterate what I said here. You want to use parentheses around all your negatives. Okay. So we want to be careful about that. So that when we match these up, if we got a -14 here, make sure it's in parentheses multiplied by the 12. Got a -3 here. We're going to put the plus because it's always plus, but then we're going to have a -3 times 2. Okay. Well, then that does give you a -6 that we had down here. Anyhow, okay. Now this one, this can sometimes throw people off, but people didn't hesitate. That's very good. People wrote this as 4x minus, well, actually, you can write it as plus -3y, which of course is the same thing then as 4x minus 3y. Okay. Okay, well, let's try this. Let's try 12 -4, 16 5 times x y. I'm not going to tell you what to do with this. There's several things that might make perfect sense. Just do what you think would be the best thing. And if you happen to do the thing that we do, the standard operation, that's great. And if not, it'll be easy to make the correction. Let's see what you do with that. Okay, now I didn't really tell you what to do with this. A couple of sensible things you could do. But the way it's going to be is I'm going to multiply each row by the column. Okay. So when we do that, we're going to put these things into another set of brackets. Okay. So we're going to multiply 12 times x negative 4 times y, and that's 12x plus negative 4 times y. That came from the first row, and we're going to put it in the first row of this matrix. Then we have what we get with the second row, which is 16x plus 5y. That came from the second row, so we're going to put it in the second row. Okay. And then we probably go ahead and write the plus negative 4y, just as minus 4y, and 16x plus 5. Okay. We're doing real well. Now, keep this. Okay. Now we're going to write this. Okay, so see what you get if you try to write that out. Okay, so if you do this, 12 times x is 12x minus 4 times y, and we'll just write the minus 4 this time. And we get 16x plus 5y. That's what we have on the left of the equal sign. Now we work the left and then we work the right. In this case, of course, to the right of the equal sign, there's nothing to work. We just have 16 on the left. Okay. Now, if this, and this is called a matrix, okay? This called a matrix, it's got a top row and a bottom row. This is called a matrix, it's got a top row and a bottom row. And the two matrices are equal. What does it mean for them to be equal? Well, it means whatever's in the top row has to equal whatever's in the top row, and whatever's in the bottom row has to equal whatever's in the bottom row. So you got 12x minus 4y equals 16, and 16x plus 5y equals 11. And of course, we've seen that before because that's just the equation we started with, right? So we could write this equation in 3 different ways. And we could write it as this. This means the same thing as this equation. Or we could write it as a matrix product. We multiply a matrix by a matrix and get a matrix. Of what we just did. These all mean the same thing. not only that, but computers know how to solve it this way, and they know how to solve it this way. You go online, Wolfram would allow you to put these in. Now I'm not gonna go tell you how to, well, I'll tell you how to put them in. You'd write 12 comma -4 comma 16. Then a semicolon to show you these go to the new row, and 16 comma 5 comma 11. And you put brackets on either side. And you'd say, reduce this. And what it would do is just this. Okay? It might even show you the steps, but it'll at least show you the final matrix. And then you know that means x equals 1, y equals negative. If you ask it, put this equation in, just put some brackets there, put 12 comma -4, semicolon for the new line. You don't have to remember this. 16 comma 5, all inside the brackets. And then you do x semicolon y in brackets. And then equals in brackets 16 semicolon 11 and ask it to solve that. It'll give you the solution, which is, what do I have? Actually, we never did solve this one because the way you solve this one's more complicated. You understand how to reduce a matrix. You don't know what to do with this, and this is as far as we go in pre-calculus. If you happen to have linear algebra in your future, it should give you a good start. It's something that often confuses people in linear algebra. Okay. Well, now we have the assignment on matrices. Okay. Some of you started it, some of you didn't. I recommend that you work it. It starts out with some kind of word problems, but then it just gets into doing this stuff. Okay. So if you don't understand how to do the first few word problems, and that can be a little confusing, we don't have time to go over that. Okay. It's good stuff. But in this support course, we're not going to talk about that unless somebody really wants to. So starting about the 5th or 6th problem, you just get into writing the augmented matrix and writing matrix equations and stuff like that. Okay. So it's worth doing that assignment. Okay. Okay, just talking a little bit about what you learned in a pre-calculus course and what good it can do you. You got a company sells widgets, which is just something you sell. Okay, whatever it is. They sell for $50, they'll sell 100 of them. If they sell for $80, they're only going to sell 60. In other words, people will pay $80, but not as many people will pay $80 as will pay $50. Okay. They're good widgets, they're worth $80, but not everybody has $80 to spend, maybe. Okay. Whatever the situation, first thing I want to do is I want to grab this information. I'll put the price here. And the number sold here. Well, if the price is $50, you're going to sell 100. So I'm going to put $50 here. I'm going to put 100 here. So I'm going to label this line y equals 100. I'll label this line x equals 50. I represent the fact that if I sell for 50, you sell 100 up by a point on the graph. Okay. Now, actually, I think I'm going to let this be x equals 80. Just because of the way you're probably copying it down. Now, can you, and of course now, this would be y equals 60. Can you put the rest of the information on the graph? Can you give me another point on the graph? Give you a minute to think about it, see if you can do something. I'm not going to wait a whole long time, so if you got an idea, put it down on your paper. Well, the other bit of information is, if they sell for 50, we're going to sell 100 of them. Well, selling price is your x. X is 80 here. Well, halfway between 0 and 80 is 40, so I think x equals 50, maybe about here. Okay. That looks like 150 cells. Rid of that one little line. So x is 50 here. And we're going to sell 100 of them, so we need y equals 100. Now 60 is here, 120 will be up here, 100 be about here. This means I probably should have made my y-axis a little higher, but you can see what's going on. And now we got a point here. Okay, well, now we assume y, which is the number sold, is a linear function of x equals a selling price. What's the function? Well, if it's a linear function, then it could be in this form. Okay, y equals mx plus b. Now, y equals 100 if x equals 50. So 100 equals m times 50 plus b. We got an x and a y. Plug in here. There we have it. Also, y equals 60. Think, yeah. If x equals 80, so 60 equals m times 80 plus b. This is just a system of two equations that we can solve for m and b. So again, we write the system. Now I'm going to write 100. I'm going to write it. Okay, I'm going to write it this way: 50m plus b equals 100. And here I can write 80m plus B equals 60. Now we should see this is the same equation. I just got the 160 on the other side. And instead of m times 50, I wrote 50m. Can you solve that equation for that system? This is system of equations. Okay. This system of equations we can write as 50, 1, 80, 1 equals, well, I'm not going to write the matrix form. I could, but since we don't know how to solve the matrix form, which is a little harder, we've got this. So now we have equation 1, equation 2. And what do? We can eliminate B. And, you know, make this look the way you'd like to see it. We're going to do one more step rather than put it in augmented form this way. I really want these ones being the first column. So what I'm going to do is I'm going to say, okay, here's the equation, but I'm going to write it this way: B plus 50m equals 100. B plus 80m equals 100. That gives me matrix equation 150, or the augmented matrix 150, 100, 180. And it's not 100, it's 60 here. Okay. Now this is easy to reduce. I don't have a lot of room. So I'm just going to say, okay, my first row is going to be row 1. And second row will be row 1 minus row 2. In other words, I do row 1 minus row 2, put it in the second row. So I've got 150, 100. And then if I do row 1 minus row 2, 1 minus 1 is 0. 50 minus 80 is negative 30. 100 minus 60 is 40. That's right. And then I write down row 1. You might have a hard time seeing this, but it's row 2 divided by negative 30. I get 150, 100. That's row 1. Row 2 is 0, 1. Negative 4/3. Then I do row 1. Make myself rewrite my instructions here. Row 1 minus 50. Room there. Things over a little bit. I'm going to do row 1 minus 50 times row 2. I'm going to get 1, 0, and 50 times 4/3 is 200/3. This is 300/3. I think I get 100/3. Doesn't make sense. Because I'm subtracting, I should get 500/3. That makes sense. Now, all we've done is we've taken this information, put 2 points on a graph to represent the information, then assume that the relationship is linear, which probably isn't, but it's not a bad beginning assumption. So this line is going to be y equals mx plus b. We plug these coordinates 50 and 100 in for y, x and y, 80 and 60 into this for x and y, and we get this equation, which we can write like this. Then we change the order of the additions and put the numbers on the other side here. And we see that these are the same equations that this is. So we translate that to matrix form. We reduce the matrix and we get this. Now we're out of room on the board, and I'll change colors so we can keep track of what we. This tells us that B is 503. This tells us that M is -4/3. That's poorly written. Might be hard to see. But this is your B, and this is your M. Then our y equals mx plus b becomes y equals -4/3 x plus 500/3. That's a linear function that models how many you expect to sell if you know what your price is. So you put your selling price in, do the arithmetic, this will tell you how many you're likely to sell. And there's more to it, but we'll leave it at that for now. Okay, in the support class, we started with this system. Okay. Now, this system can be written with brackets if we wish. And in different ways, but first thing we do is we write the system as an augmented matrix. And then we simply reduce the augmented matrix. The reduction ends here. And I'm not going to go over the details of that because I think we've been over the details of augmented matrices quite a bit. And we end up with x equals +1, y equals negative. Okay. Then we check. And it checks out. So there's nothing particularly unusual about that. The one thing is that instead of multiplying the first row by 16 and the second row by 12, I multiplied the first row by 4 and the second row by -3. Why would I do that? Well, we do the prime factorization. 12 is 2 times 2 times 3. 16 is 2 times 2 times 2 times 2. We can note that the least common multiple is these numbers that both have in common. Each has a pair of 2's in common. Now, the 16 has an extra pair of 2's that the 12 doesn't have. The 12 has a 3 that the 16 doesn't have, but they do have in common a pair of 2's, and that's your least common multiple. That's okay, or I'm sorry, least common denominator, least common factor, called a denominator, least common factor is 4. If these were denominators, it would be the least common denominator. Okay, now the least common multiple, if we look at these numbers, what do we need to have a number that's a multiple of both of these? Well, first, to be a multiple of 12, it has to have a 2, a 2, and a 3. So we start by writing 2 times 2 times 3. We know that the least common multiple has to have this. Is that enough to give us the 16? Well, no, the 16, the 2 and the 2 match up with these 2's, but there are 2 more 2's that the 16 needs. So if this number is going to be a multiple of both 12 and 16, it needs an extra pair of 2's. Now it contains 16. 16's right here. These 2's and these 2's. 12 is right here. Pair of 2's and a 3. So there's your least common multiple, which is 48. Now, what do we have to multiply 12 by in order to get this? Well, 12 has 2 2's and a 3. We need a couple more 2's, right? So if we multiply 12 by 4, we're going to get our least common multiple, which is 48. So we multiply the first row by 4. That's going to give us 48 here. What do we do with the second row? Well, 16 has these 4 2's. What does it lack? It lacks the 3. So if we multiply 16 by 3, we're going to get this, which is again the least common multiple. So we multiply the second row by 3, and we put a negative sign on that 3, so we don't have to worry about subtracting negatives. Okay? Yeah, if they should arise. Okay. So now we can just add the rows. So in the next iteration or next step, we just write the first row. We're not going to mess with that. We know that we want a 0 here. Our process, we should be used to it by now. We're going to want a 0 here and a 0 here and a 0 here. Once we have that, well, this is what it's going to end up, and it's going to be a solution to the equation or to the system. Okay, so what do? Well, we've got these lined up, so if we just add row 1 and row 2, we get a 0 in the first column. Okay, so we write down row 1, and then we add row 1 to row 2 and put it here. So row 1 and row 2 adds up to 0 here. 16 and negative 16, negative 15 adds up to negative 31. 64 and negative 33 adds up to 31. I will note, if you have to watch the support class video, I wrote a negative 64 here and got all the way down to the check and realized that it was wrong. Okay, fortunately, it's real easy to correct it. So anyhow, you see how that worked out if you're interested. And if you see me do this with a negative 64 here and get the wrong answers, yeah, it's worth saying because that's stuff people do all the time. I do it more than anybody else. People do it all the time. Okay, now here we have this augmented matrix. What do? We want to one here. I think we want to. Before I said we want 0 here, 0 here, 0 here, 1 here, 0. Okay, we want a 1 here. Well, that's going to be easy to get. If we divide this row by negative 31, we're going to get 1 here. So we do that. We write down first row 1, and then we divide row 2 by negative 31, and we get what we get. Okay, then it's a simple matter of to get a 0 here. We multiply the second row by 16 and add it to the first. It's the first row plus 16 times the second. Gives us 48, 0, 48. I will mention, you might see this. Probably isn't worth the trouble of an extra step, but we could divide this first row by 16 and get 4, negative 1, negative 4. Numbers would be smaller, so we'd have 4, negative 1, negative 4 here. But we didn't do that, and I chose not to do that, even though it would have been a pretty obvious step. Okay. So that would have been a valid step. I'm just mentioning that. Continuing with what we have here. Well, there it is. We copy it down again. We just write row 1 as it was and row 2 as it was so that we can see exactly how this relates to this. We divide the first row by 48 and we get our solution. Okay. So that's the details. What I was really addressing though is why we chose to multiply by 4 and -3 instead of 16 and 12. All right. Now let's see what's next. Yeah, let me pause until I locate the right board. Okay, so first of all, this and this mean the same thing. Okay. Now there's another way to write out this system. Here it is, but let me explain. This process is actually very simple. If you don't pick it up from what I'm saying, look at the early part of the video. I'm putting both the support class and the regular class videos together today. Okay. First thing you need to know is how to multiply a row by a column. Now, if you've done, some of you have done the matrices homework and done it right, let's make sure we understand and easily, review maybe what's going on. Okay, the 5, 7, 3 is a row. It's in brackets. Put brackets around a column of 3 numbers. And I've got a row times a column. And this is important. I didn't mention it in the support class. But the row and the column have to have the same length. They have to have the same number of numbers so you can match them all up. And then what you do is you just match them up. You take the first number in the first row times the first number in the row times the first number in the column. That's 5 times 2, and you write it out. And then the second number times the second number, then you write that out. And then the third number times the third number, then you write that out. It's very simple. You multiply this by this by this, and this by this. Okay. And then you can do the arithmetic. I think that comes out 46. But once you have it in this form, I trust you to do the arithmetic. And unless the numbers are very simple, you're probably going to use a calculator to do that. That's okay. As long as you write this out, that's okay. The calculator tells me we get this. Another example, we've got a row of 4 and a column of 4. So we can multiply those. And we do exactly the same thing. We match up the 8 and the 5, the 12 and the -14, the -3 and the 2, the 4 and the 7. And we get these numbers that I think add up to -106. Okay. Now we do another one. And people have no trouble doing this. Okay. Which is 4 -3 multiplied by xy. Row 4 -3, column xy. We match up the 4 with the x and the -3 with the y. So we get 4x here and -3y here. And it's actually 4x plus -3 times y. But that is the same as 4x minus 3y. Well, now, one more process or one more step in the development. Here, I've got a row consisting of, well, I've got a matrix, set of brackets around a bunch of numbers. That's a matrix. Well, okay. These are, this is a matrix, okay? I'm not going to define matrix right now. Okay, so we got a row here, and we've got another row here. So we've got 2 different rows multiplied by the same column. What do we get when we multiply the row by the column? Well, if we multiply the first row by the column, we get 12x minus 4y. We put that in a new matrix in the first column. Okay, so it comes from the first column, it goes in the first column. Then we do the product, 16,5 times xy, 16x plus 5y goes in the second column. And then I rewrite it. I wrote the 12x plus -4 times y to be careful. We know that's 12x minus 4y. And then 16x plus 5y is as it is. Does that make sense? Okay. So what I'm going to ask you to do now is multiply two matrices. So let's just do this. 3, 5, -2, 7. And we're going to multiply this by -4, 2, 6, -1. Now, we do this by multiplying rows by columns. So I'm going to see how I can do with this. Okay, now some people got it, some people did something else that's kind of obvious. But there's no such thing as row times row. Okay. And some people just did first row times first row, second row times second row, which makes perfect sense if you don't know the rules. Okay, so it wasn't a bad thing to do. It just it doesn't fit into the idea of rows multiply columns. Okay. If we multiply rows by columns, actually, I'm going to give you just a couple more minutes to correct that. And if you everybody wrote out the products and exactly as I'd like to see them written out. But go ahead and do the multiplications now and additions and see what numbers you get. Okay. So what we got here is we multiply rows by columns. Okay. So let's just start by underneath number. Multiplying the first row by the first column. Okay. I'll just kind of note that over here. That's going to be 3 times negative plus 5 times 6, which is -12 plus 30, which is 18. Okay. Now that came from the first row and first column. So the first row and first column of the matrix that we're going to form here is right here. So not much choice about where to put that. Since it came from the first row and first column, we put the number in the first row, first column. Then we multiply the first row by the second column. Okay. And I'm not going to put the 18 there. I'm going to put the calculation. Okay. Now put the calculation here. I leave a little space between here and here. We're not going to add any, the first row times the second column. We're just going to do the first row times the second column. And we're going to put it in the first row, in a second column of this new matrix. Okay, so I've got the matrix set up. I've got a first row, and I've got room for column here, and I've got room for column here, and a second row down here. Okay, so I do them 3 times 2 plus 5 times -1. Okay, then what? Well, now I start with the second row. I do the second row times the first column. I get -2 times -4 plus 7 times 6. And then I do second row, second column. -2 times 2 plus 7 times -1. Okay. So again, I can see my numbers from the first row, 35, right here. Okay. And the 3 to 5 will be right here too. Okay, from the first row, there they are from the first row. In the first column, I can see the -4 and the 6. There's a -4 and the 6. There's a -4 and the 6. Okay, second column, I can see the 2 and the -1. Second row, I can see the -2 and the 7. Okay, so if you want to see that pattern, be sure you're doing it right. It's a simple enough pattern, and once you see it, it's pretty obvious. Okay, because that's a good pattern. And we haven't proven that it has any mathematical significance, but you would not believe how much mathematical significance this process has. Okay, so we've got -12 and 30, which is 18. We've got 6 and -5, which is 1. We've got 8 and 4, 8, 42, which is 50. And we've got -4 and -7, which is -11, if I've done that correctly. Okay. Now, there are plenty of other patterns within matrices. As a matter of fact, starting with what we've done so far, everything can just explode into something as profound as the foundations of quantum mechanics. Okay, and you would not have any appreciation at this point, probably any point, of just what the implications of that are. I've just got a better notion myself. And you're probably not going to follow the path of becoming a mathematician. Okay, probably have other things to do with your life. So anyhow, of course, most of you are going to become physicists, so you're going to have to learn some math, isn't it? You're not going to become a physicist? What's the matter with you people? Okay. Okay, yeah, I would not encourage that. Okay, so anyhow, that's how you multiply matrices. Okay. And let's just do one more. Same principle is going to apply. Let's see if you can apply the principle to doing one like this. Now, if you can multiply the rows by the columns, then you can multiply the matrices. And you want to multiply every row by every column and put it where you think it belongs. Okay, not everyone is done, but I see what everybody's doing for the pattern. In some cases, every case it starts out right. I'm not sure it continues right in every case. So let's just do this. Now, I'm leaving myself plenty of room here. And the reason I'm leaving myself plenty of room is I'm going to need plenty of room. And, I'm not sure the board is totally visible. There we go. So this is a problem you should be working on if you pause and work. Okay, so people have worked on this for several minutes and making good progress. Everybody started by multiplying the first row by the first column, which is very good. Okay, so that's 2 times -1 plus 3 times -4 plus 5 times 5. Okay. This, this. Okay. Then some people started by doing the first row by the second column. And others started by doing the second row by the first column. So I'm going to go ahead and do the second row by the first column. Okay, I think everybody did that. Whether they started one way or started the other. Okay, so we've got 1 times -1 plus 3 times 4. 3 times -4. Okay, and plus 2 times 5. Okay, 1 times -1, 3 times -4, 2 times 5. First row, second row times first column, and it goes in the second row. It also goes in the first column. This came from the second row in the first column. Okay. Then we're going to multiply the first row by the second column. So we're going to have 6 rows, row times column products. First row times each of the 3 columns, that's 3. Second row times each of the 3 columns, that's 3 more. So we've only got 2 of them, only a third of the way done. We're having so much fun, we don't mind. Okay, now, first row times second column, 2 times 4, plus 3 times -2, plus 5 times 3. Trace that out, make sure I wasn't looking cross-eyed or something. 2 times 4 is there, 3 times -2, and 5 times 3. Okay. Trying to keep my sleep out of the way, it's distracting. Okay, then I'm going to go ahead and do the first row by the third column, so I'll be done. First row done. So it's going to be 2 times 6, and then 3 times -5. All that bracket there. Make that bracket a little bit shorter. Give myself room to write the last part, which would be 5 times -1. Now, there are a lot of calculations involved. I want to make sure we've not made a clerical error. I'm tending to make a lot of them. 2 times 6, 3 times -5, 5 times -1. I've got that all. Okay, well, now I'm going to write them out a little more quickly. The second row times the second column will go in the second row and the second column. Okay, so 1, 3, 2, that's 1 times 4, plus 3 times -2, plus 2 times 3. 1 times -1 times 4, 3 times -2, 2 times 3. Okay, then I'm going to have 1 times 6 plus 3 times -5 plus 2 times -1. To double check or to triple check, I've already kind of double checked. What I should see in all the ones in the first row should be 2, 3, 5. Well, there it is, 2, 3, 5, 2, 3, 5, 2, 3, 5. This is my first row. 2, 3, 5 is my first row. It has to appear throughout my first row. Second row, 1, 3, 2 has to appear. 1, 3, 2, 1, 3, 2, 1, 3, 2. So I got that copied down right against all odds. Okay. Now the first column, I better have -1, -4, 5. Well, -4, 5. And -1, -4, 5. Let's look over there. I'm looking at the first column, which would be here. Okay. -1, -4, 5 in the parentheses. Lined up. It's nice to line these up. There it goes. Okay. Then what? Second column is going to have 4, -2, 3. 4, -2, 3, 4, -2, 3. Right there they are. They're all nicely lined up. Okay. And then in the third, the 6, -5, -1, 6, -5, -1, 6, -5, -1. And there we have it. Then we do the arithmetic. Okay. That's -2 and -12 is -14. and 25 is 11. That's 8 and negative 6 is 2, and then 15 is 17. That's 12 and negative 15 is negative 3, and another negative 5 is negative 8. Oh man, that H does not cooperate. Hard to make an 8 out of this answer. I could analyze the physics of that for you, but you don't want to know. Okay, so we got negative 1 and negative 12 is negative 13, but we have 10, that leaves us negative 3. We have 4 and negative 6, which gives us negative 2, and add 6, and we get 4. And then we have 6, negative 15, gives us negative 9, another negative 2 gives us negative 11. So there it is. That's matrix multiplication. There's nothing difficult about it, just takes a little practice. We have written out several matrix multiplications. You're unlikely to have to practice, and if a matrix multiplication problem appears on your exam, well, you won't be completely prepared, but hopefully you'll be able to take it correctly. Okay? But you don't want to have any question about what those were. The rules are very simple. You multiply rows by columns. Whatever the row and column is, that's where it goes. Okay? Row 1 times column 1 gives you 11. Row 1 times column 2 gives you 17, which is in row 1, column 2. Row 1, column 3 gives you negative 8, which is in row 1, column 3, and so forth. Okay? So if I have a matrix with 10 rows and 14 columns, I can multiply that by a matrix that has 14 rows and 28 columns. As long as the number of rows of the second matrix equals the number of columns of the first, I can multiply them, because in that case, the rows will match up in length with the columns. The rows are 3 long, the columns are 3 long. Okay? If I wanted to put 2 or 3 more columns here, well, I can spread out this way. But as long as the columns all have 3 numbers in them, they can be multiplied by these rows. Just kind of common sense. Okay? Now you have rules. He says they have to be compatible, and here's a rule, and here's a rule, and here's a rule. It's a good way to present it. I think what we've done is a better way for most people, just an experience. In a linear algebra class, I'd be in some much higher level class. I'd probably do it with definition, not apply the definition. Okay. Now we move on to an example, and the example is going to kind of tie into a lot of the content of the whole course. Now, Thursday or last class, we'll do some reviewing, just so you know what's important, what isn't. And I'll probably try to come up with some sample problems. If not before Thursday, at least hopefully by the weekend, so you have something to look at. But you've got the open math assignments. You can go back and review the open math assignments. Okay? You can do selected problems from the half credit assignments. Okay? You've got a lot of stuff to practice. Okay, well, I'm going to skip now to an application if I can find it. I've already worked a lot on it. Give me the back of this one. Yeah. Okay, so this is an application problem. here's the problem. A company sells widget. Okay, let me back up. Just on the matrices. Understand that this means the same thing as this. Means the same thing as this. Okay? If you multiply this out, you get the equation. I'm not sure we really addressed this here, but we did in the earlier part of the video from the actually let's just make sure we got that. Okay. So I don't think we did one like that. So let's write this out. Write this product out. And then multiply the matrices. We multiply these matrices. If I multiply this matrix by this, I get 12x minus 4y. Row times column. Row times column gives me 16x plus 5y. So this multiplication, do rows times column, I get this matrix. And this is all I get when I do that multiplication. Now we still got an equal sign, which doesn't go inside this matrix. There's nothing's going to take that equal sign inside of the matrix. That equals 1611. Now, if this matrix equals this matrix, then whatever's in the first row of this matrix has to equal whatever's in the first row of this matrix. They wouldn't be equal if this wasn't equal to this. So that tells us that 12x minus 4y equals 16. And similarly, whatever's in the second column has to equal whatever's in the second column of the other matrix. So, okay. And of course, that's just the original system. Okay. So we want to understand that all these things are equivalent. And I think I commented in the other class that once you've written either the matrix equation or the augmented matrix, two different things, and they're operated on in two different ways. But once you've written these two things, you can put them into, say, Wolfram Alpha or some other computer algebra system. It's free, it's easy, okay? So you just write in. Now I'll just tell you, just do 12 comma negative 4 comma 16. Semicolon, which tells you now we'll go to a new line. 16 comma 5 comma 11. You would not write those commas on your paper, but you have to tell Wolfram Alpha where one number starts and the other stops. Okay? And you write that down, and then in front of that you write row reduce. And you know what it's going to do? It's going to spit out. I don't know if I've still got it up here. It's going to spit out that matrix 1, 0, 1, 0, 1, negative 1. It'll tell you your solution. Or if you put this matrix product in here, then you can do things with that matrix equation. Okay? And those are important things. Now, we'll move on. An example. I don't know what this box of chalk is doing here. It's going to get all broken up if I don't pick it up. Then, and so just get me all broken up. Okay. Actually, I think I'm emotionally strong enough to handle it. Okay. I think. Here's your problem. Company sells widgets, and if they sell for $50, 100 is going to be sold. Okay. So I've got this company. I'm selling these widgets, whatever widgets are. Okay. And I know every month, if I sell them for $50, people are going to buy 100 of them. Okay. Now, if I jack up the price to $80, yeah, some people are going to get mad, some people won't be able to afford it, some people don't think they're worth $80, but they're really good widgets and they are worth $80, and a lot of people will still buy them. So I find that I can sell 60 of them for $80. Now, if you do a little quick mental arithmetic, you see that I'm better off selling them at $50 than I am selling them at $80, because 50 times 100 is 5,000. 80 times 60 or 60 times 80 is 4,800, which is $200 less. So I'll get $200 less in a month. It won't be a big difference, but of course, you know, $200 is $200, especially if it's at my margin. Okay. Now, and that's probably what it is. Okay. So, however, these two are pretty close. Okay. So I could ask myself, well, what would happen if I sold them at $60 or $70? I know this, don't know about $60 or $70. So what I do is, first thing I do when I've got data, and we've talked about this early in the semester, whenever I've got data, I put it on a graph. Okay, so what's my graph? Well, the number sold seems to depend on the price I set. Okay, so we do a graph. Price is independent. I can set that any way I want to. That goes on the horizontal axis, and the number sold goes on the vertical axis. So here's my graph. A lot of stuff ended up getting crammed in on this board, but okay, so I got the y-axis, y equals the number sold, x equals the price. Okay, and I could say in dollars. Okay, well, if I sell them for $50, I sell 100. So that means when x is 50, y is 100. So I draw myself a little vertical line for x equals 50 and a horizontal line for y equals 100. And where those lines intersect, I put a point, because that indicates if I sell them for 50, I sell 100. Okay, then x equals 80, because selling price $80. I know I sell 60, so I put my x equals 80 line here, my y equals 60 line here, and I put a point there. Got 2 points on the line. Now, I don't know what's going to happen between here and here, but I kind of suspect, I don't necessarily suspect, but the best guess is, or I expect it's going to be pretty close to linear. Okay, so I just hypothesized, well, there's a straight line from here to here. So if I sell between $50 and $80, that straight line's probably going to tell me what I'm selling. So for example, if I want to sell for $60, say here's 60. And if this is 60 and this is 100, it looks like maybe I'm going to sell, let's see, that'd be 80. It looks like I'm going to sell maybe 82 of these things. And 60 times 82 is 4,920. Okay. And if it's 85, well, it's even a little better. Still not quite equal to the 5,000. If I sell it for $70, so I can do this. And this should be familiar to you. I shouldn't have to write numbers in this. We did this first thing, almost first thing we did in the semester. We figured what y is for given x, what x is for given y, and how to do that on the graph. So I assume we can do that. It looks like maybe we would sell, if we sell them for $70, it looks like maybe we would sell about 75 of them. And 75 times 70 is 5,250. That's more than the 5,000 I get selling at 50. So I kind of think that somewhere in between there is a sweet spot. What point on this linear curve or this linear graph would give me the best revenue? All right. Well, you know, first thing I'm going to do, I'm going to find the equation of this line. Okay, well, that's something we did pretty early in the semester, and it's something you really need to know how to do. Okay, if you got 2 points in line, you gotta be able to find the equation of the line. And the way we do that fits right into what we've been doing. Okay, we say that, okay, first of all, if it's a line, it's got, the equation could be written y equals mx plus b. Okay, now if it's y equals mx plus b, we know that when x is 50, y is 100. So when x is 50, y is 100. So we replace x by 50 and replace y by 100, and we get this equation right here. Y is 100, x is 50. We know that this is so. Okay. We don't know for sure that the thing is a straight line, but if it is, we know that this is one thing that helps us relate M and B. Now, at this point, we've only got one equation, and we got two parameters. M and B are what we call our parameters. And you should know, and if you don't, start doing some heavy reviewing, that M is a slope and B is a y-intercept. Okay? We're not particularly interested in the y-intercept because we're pretty sure that the linear model isn't going to work all the way up to the y-intercept. But we think between here and here it works. Okay, so anyhow, we take this other point. We got 2 points, we get two equations. We got an x and a y here. X is 80, y is 60, so we let x be 80, y equals 60, and right there we got it. Now, what is this? It's a system of two equations and two unknowns. That's what we've been doing. We put this into matrix, reduce the matrix, and figure out what our slope and our y-intercept are. Okay, so again, things are a little scattered here, but we take these two equations. Now, I wrote, assume that number y sold is a linear function of x, which is the selling price, so that y equals mx plus b. Y equals 100 if x equals 50, so we get this equation. Y equals 60 if x equals 80, so we get this equation. So we rewrite those equations up here, but I took a little bit of liberty and switched the sides. And instead of m times 50, I wrote 50m. Instead of m times 80, I wrote 80m. Order of multiplication doesn't matter, so that's okay. So other than that, and the fact that the right-hand side is on the left now, and the left-hand side is on the right in each equation, it's the same. Okay. Now, if I was solving this without doing a matrix reduction, I just rewrite the system, but I'd multiply the second equation by -1. And I'd end up with a b and a negative b. I'd add the two equations, and I'd end up with -30m equals 40. Okay? So m would be -4/3. I'd plug that back into the first equation and solve for b. That's perfectly valid. You should know how to do that. Okay? So make sure you know how to do that. Then, instead, I decide just to illustrate the row reduction and stuff and the value of it, because that's what we've been talking about, augmented matrices. Also because it's a handy way to solve it. I switch the order of addition. I put B first. Okay. If I put B first, then this can be represented by the augmented matrix 1, 50, 100. Just like this was an X and this was a Y, but it's a B and an M right now. So, and 1, 80, 60. Right there's my matrix. Okay. Then I row reduce the matrix. Now I went through the steps in the early part of this video in the support course. Not everybody was in the support course, but it's straightforward. We reduce it. How we're going to get a 0 here, we're going to subtract the first row from the second, or the second row from the first. That's going to make this 1 into a 0 because we have ones. Okay. And we do that, we get this. Okay. And then what do? Well, we divide that -30 by 30, and I get 1, -4/3. So now I know that m, my second variable, is negative 4/3. Okay, that's the slope of my line. And of course, I can draw a fundamental triangle and find that the slope we get agrees with that. Okay, so do this. Our fundamental triangle, which I haven't labeled, or I could label, this is negative 40. And this is 30. The fundamental triangle tells me what the slope is. I could have used it in the first place, but I wanted to illustrate the matrix reduction. Okay, but what I just got was m equals negative 4/3. Totally agrees with the fundamental triangle. So I'm pretty confident that my slope is negative 4/3. Now I complete the reduction. I just add negative 50 times this to this, negative 50 times the second row to the first, and I think I get 500/3. Okay. Now I haven't double checked that, and I could, but I don't want to take the time. You can double check it. Okay. So y equals mx plus v. M equals negative 4/3, v equals 500/3. So now I know that y equals negative 4/3 x plus 500/3. Okay. So now I know if I tell you what the set price is, you can tell me how many I'm going to sell. Now, how much am I going to make? I've got 5 minutes. And there's 2 or 3 really important connections I want to make. So, I'm going to move on. But I'm going to try to okay now. Y is your number sold, X is your price. How much revenue? Well, I mean, if I sell 100 of them for $50, I get $500,000 of revenue, right? I multiply the number I sell by the price that I sell them at. So revenue is the price times the number sold. In this case, the price is X. And we multiply that by the number sold, which is Y, which is negative 4/3 X plus 500/3. And what do we get? We get negative 4/3 X squared plus 500/3 X. What's this? It's a quadratic function. It opens downward because we have a negative coefficient on X squared. So that the graph of this thing, well, negative b over 2a, and this b is no longer the b for the linear function. This is how we graph a quadratic function. Okay, just go back to how we graph a quadratic function, all things about the axis of symmetry and the location of the vertex, right? Well, let's see. The threes will go away. We get negative 500 over 4, which is negative 250 over 4, which is 62.5. Okay. Seems a little low, so I'm not sure about that 500 thirds, but it's not unreasonable. You charge $62.5. Okay, so now we have this. Supposed to be an hour, the board's shaking. Either that or I am, I think it's a board. Okay, revenue. I'm gonna write mine, read that. Hold the board still, stay there. Revenue. Quadratic function. Let's bring this over so it'll flood the board so that it'll. Okay. Here's your graph. Here's your revenue. Your revenue is a quadratic function. There it is. Right here is vertex. Okay. And this says, okay. Let's see, when x equals 0, the revenue is 0. X is your selling price. If you don't sell them for anything, you just give them away, you don't make any money. You don't collect anything. So you got a point here. You're going to have a peak on your axis of symmetry. And then symmetric with that, you'll have the other side of the parabola. Your peak revenue is at the vertex. Okay, well, we're out of time. I'll say a little bit more on this, but you might want to talk to those representatives if you're interested in transferring to that one institution. They'll be there, I think, until 1. But you know that it's easy to calculate the coordinates of the vertex if you remember how to graph a quadratic function. So that knowing matrix multiplication, knowing how to find the equation of linear function, knowing how to graph a quadratic function, gives you some useful information that it actually is used in that form in business. Now there are modifications to that model that get somewhat more complicated. Okay? And if you're in business, you need to be able to build on this model and think in terms of other models. Okay? So, review.